Hey guys, welcome back. Today we're going to be talking about kinetics. So first, talking about rate of appearance / disappearance. So if there's a reactant in a reaction, it's disappearing and forming a product, which is appearing. And so we measure the rates of disappearance of the reactants and appearance of the products. So with this reaction here, this example, A plus 3B yielding 2C, where A, B, and C would be compounds, obviously. A, with the stoichiometric coefficient of 1, let's say has a rate of disappearance of 1 molar per second, let's say. That would mean that since the stoichiometric coefficient of B is 3, the rate of disappearance of B would be 3 times the rate of disappearance of A. So in this case, it would be 3 molar per second. And since the coefficient of C is 2, it would be 2 times the rate of disappearance of A. And so the rate of appearance of C would be 2 molar per second. Let's take a look at some problems. A scientist conducts an experiment to determine the rate of the following reaction. If the initial concentration of N2 was 0.5 molar and the concentration of N2 was 0.45 molar after 0.1 seconds, what's the rate of the reaction? So the way we're going to want to approach this problem is in the following way. We're first going to want to take the initial concentration and then subtract it by the final concentration over the change in time. And we're going to multiply that by the following ratio. Since the rate of reaction is equal to the rate of disappearance of N2, since the coefficient is 1, we don't actually have to do any extra math. And so the actual rate of the reaction would be 0.5 molar per second, so A. Let's take a look at another problem. A scientist conducts an experiment to determine the rate of NO formation in the following reaction, same reaction. And with the same numbers, what is the rate of NO formation? So we're going to approach this problem similarly to the previous. We're going to take the initial concentration minus the final concentration over delta T, or the change in time. But this time, we're going to multiply by the difference in rate of appearance. So since the stoichiometric coefficient of NO is 2 and the coefficient of N2 is 1, we're going to multiply by 2, which is going to be the rate of appearance of NO, over just 1, which is the rate of N2. And so the rate of formation comes out to be 1 molar per second. All right, let's take a look at another problem. The rate of formation of ammonia is 0.345 molar per second. What's the rate of disappearance of H2? So same thing, we're just going to use the stoichiometric coefficients here. We're going to take the rate of formation of ammonia and multiply it by 3, which is the stoichiometric coefficient of hydrogen gas, over 2, the stoichiometric coefficient of ammonia. And that'll give us the rate of disappearance of hydrogen gas. And so we get about 0.518 molar per second. It's going to be this one. All right, so now let's talk about rate laws. So reactions have rate laws, and depending on the order of the reactant, which we're going to look at in a second, then we can determine the rate law. So let's say we have a reaction where A in respect to A is second order, in respect to B is first order, and in respect to C is 0th order. The rate law will be rate equals K, which is the rate constant, times the concentration of A to the power of 2, times the concentration of B to the power of 1, and there's an unwritten times the concentration of C to the power of 0. But anything to the power of 0 is 1, and so we can eliminate that from our rate law. Let's look at a couple example problems. All right, so for the reaction 2A plus B plus 2C yields D plus 2E, the rate law is rate equals K times the concentration of A to the second power, times the concentration of B to the first power, times the concentration of C to the first power. So which of the following statements is false? So we can see here by the exponents that A in respect is second order, in respect to B is first order, in respect to C is first order, and the sum of these, which is 4, is going to be the order in respect to the entire reaction. So now we can just go through the choices. The reaction is in second order to A, so that's true. The reaction is in first order to B, and the reaction is fourth order overall, but it's not second order to C, it's first order. So we can circle C for our answer. Okay, for the second practice problem, the reaction 1A plus 2B plus 1C yields 2D plus 1E. The rate law is rate equals K times concentration of B squared times concentration of C to the first power. So again, which of the following statements is false? In this reaction, in respect to reactant A is 0th order, in respect to reactant B is second order, in respect to reactant C is first order. Therefore, in respect to the entire reaction is third order. Keep in mind that we're only looking at the orders of the reactants because the rate law is based on the reactants, not the products. So we can see here that the reaction is not first order in A, it's 0th order in A, and we're looking for the false statement, so it's just going to be A. All right, now let's try to apply this to one more problem. So here we're given a table with the following data, and we have to determine the rate constant of the reaction. So the first thing we're going to want to do here is we're actually going to try and figure out how each reactant in respect what order in respect to those reactants is the rate law. So let's start by looking at the difference between trial 1 and trial 2. The difference in NO is 1/2. The difference in Cl2 is 1. And the difference in the rate law is 1/4. So what does this mean? Well, we don't actually have to look at the Cl here. And so that means that as NO decreases by a factor of 2, the rate decreases by a factor of 4. And 2 to the power of what is 4? 2. So NO will be second order. All right, now we can do the same thing, but for trials 2 and 3. So the change in NO is 1, the change in Cl2 is 4x, and the change in rate is also 4x. So as Cl2 increases by a factor of 4, the rate also increases by a factor of 4. And 4 to the power of 1 is 4, so Cl2 here is first order. So now that we have the order in respect to both of our reactants, we can find the rate law, which we know is rate equals K times NO to the power of 2 times Cl2 to the power of 1. And so now we can choose, honestly, any of these three trials and plug in the numbers for NO, Cl2, and rate, and solve for K, our rate constant. Okay, so here I went with trial 1, plugged in the rate and the concentration of NO and Cl2, and therefore isolated K. And make sure you note your units for K, because the molarity, it could be molarity, to the -1, the -2, -3, it can be anything. So here K ends up equaling the rate over the concentration of NO to the power of 2 times concentration of Cl2 to the power of 1. And make sure to keep track of your units, and you get about 38 molar to the -2 seconds to the -1. And so that's going to be C. All right, that's all I have for today. I hope you enjoyed. Make sure to like and subscribe.